Welcome to Unit 3, Lesson 1. We are finally to Unit 3. Oh, this is refreshing. We get into one of my favorite topics, and I know you are all going to cringe, trigonometry. But before we start frolicking through the fields of trigonometry, we should first look at angles. Okay. Oh, hey, my virus protection, Windows Defender, antivirus, and Semantic so-and-so is such and such a thing. It's terrible. Anyways, let's take a look at this, okay? Let's just dive right in. All right, angles in standard position, okay? First thing I want to point out, whether it's trigonometry or just angles in the unit circle or angles and triangles, whatever, angles in general. When we get to this level, I'm going to make a comparison here before I even say anything to you. When we wrote equations, we would always say y equals. Then at some point, we did this, f of x equals, and called it a function, okay? We just kind of changed that up on you, all right? Ultimately, they're both equations, okay? But this little theta symbol here, that's basically, it's just a variable. I'm going to abbreviate. Like x is a variable, okay, that gets used to represent or for angles. Now, you'll see me do a symbol like that or like that. That can mean angle, okay? Now, it doesn't mean anytime we have an unknown angle, they're going to use theta. Sometimes they can use x, for example, and you don't have to write this down. I just want to, kind of drill this home. If I have an angle right here, okay, they can say, okay, what is that angle? They use x for a variable. What they also can do is they can use theta, and you'll say, what is that? That's just an unknown, like x would be, okay? So it's just a variable, x, y, r, h, whatever. Just a variable, but it gets used in angles a lot, all right? Now, we have these two terms next, initial ray versus terminal ray. If I am going to draw an angle on an axis here, okay, I always start right here on this axis. And then maybe my angle goes up like this, okay? This is my angle. I don't know what it is, so I'm just going to call it theta. My initial ray, that's the starting line for my angle, okay? So my initial ray, and I'll do this in another color, my initial ray is this line right here. That's where I start, at 0 degrees, okay? My terminal ray, well, that's not the starting line. That's the ending line for my angle, okay? So if the initial ray is where it starts, the terminal ray, or you'll hear this called terminal side, I'll write side here because they are synonymous, is this line here. That's where my angle stops, okay? Terminal stops, initial begins, okay? I don't think it's too difficult yet. It won't get difficult, stop it. Now, the last thing on this slide, all right, we can have a positive rotation or negative rotation, which can give us positive or negative angles. Positive rotation goes counterclockwise. Okay, positive rotation goes counterclockwise. Negative rotation, well, you guess it, that would go in a clockwise motion. So what does that mean? If I have an axis here, and I start an angle, there's my initial ray, going this way to create an angle is in a positive direction. Okay? If I have a set of axes here, okay, and I start here, going this way would be a negative okay, rotation, which would give me a negative angle. All right, so this angle might be down here, so maybe it went negative 60 degrees or whatever. This angle might be here, maybe it went positive 70 degrees or whatever. But that's the difference. And why do we do that? My only guess is, and I think I'm right here, if I number these quadrants, isn't this quadrant 1? Isn't quadrant 2 this way? So that's the natural flow. So if I'm going in a positive manner, I'm going up in my quadrant numbers from quadrant 1 to 2 to 3 to 4. If I go backwards, if I go from 1 to 4, that's going backwards. That's going in a negative, okay? It's going back, all right? So you can think of it that way if it helps you remember. Let's practice some of these. If you want to pause this and go ahead and do these three, A, B, and C, go ahead. I'm about to do them right now. There's nothing difficult with them. It's not rocket science. It's just drawing an angle on an axis, okay? Let's start by drawing axes for all of these. Now, 60 degrees. If I start at 0, this would be 90 degrees. 60 is kind of almost 90. There's no way to exactly do this. That's why they say the word sketch. I don't know if I start here, I don't know, maybe something like that. That's 60 degrees, and that's positive 60. Okay, now, that's good. That would receive full credit. If you did something like this is obviously not 60 degrees. This is obviously not 60 degrees. You got to make it pretty good to where it should be. That's about 60 degrees. No teacher is going to take out a protractor and measure that if you don't have one to make it exact. But what they're going to do is notice that, hey, if I draw something like this, that's obviously from here to here not 60 degrees. If it's obviously wrong, ooh, look at that, bang, bang, they will mark it wrong. But for this case, bang, that's about 60. That's good. All right. 315 degrees. Let's do this in green, okay? This is 0 degrees. This is 90 degrees. If I go another 90, this brings me to 180 degrees. If I go another 90, I go to 270. Then if I go to another 90, it brings me back. Yeah, I'll be okay. It brings me back to 360 degrees, okay? So 360 degrees is a complete circle. I want to go 315. Now, 315 degrees is more than 270, but it's less than 360. In fact, it is right in between. Okay, if I go 45 degrees past 270, or 45 degrees before 360, that will give me 315, okay? So I'm going to do something that's going to start here, and it's going to almost be exactly, well, it is going to be exactly in between, but I'm going to try and draw it in the middle of that 90 degree in quadrant 4. So from here all the way to here, that's 315 degrees. All right? Now they give us a negative one. That's fine. That's cool. We can do negative angles. All right? I'm going to do this in blue because I like to coordinate, color coordinate. Now, if this is 0, but I go negative, I'm going to be going this way, right? Isn't our negative angles, aren't those the counterclockwise we just discussed right here? They are. So I'm going to look at this angle, and I'm going to go negative, which means I'm going to go to clockwise direction 150 degrees. Okay? So this would be negative 90, right? This would be negative 180. Okay? So negative 150 is in between those two values. Negative 150, all right, if I start at 0, negative 150 is closer to 180 than it is to 90, okay? So negative 50 is going to be closer to negative 180 than it is to negative 90. So all you got to do is just make it closer to it than 90. Don't put it right on 180 because that would be 180 degrees. So that's negative 150 degrees. All right? It's not crazy. It's not difficult. It's actually, dare I say the word, fun. Yeah. Anyways, let's move forward. Coterminal angles. What is a coterminal angle? They are asking us to find one coterminal angle for the given angles listed for A, B, C, and D. All right. First, let's define what a coterminal angle. Coterminal, co means kind of like they share. If you're a co-worker, you mean you both work at the same place, right? You share that workplace. You're co-workers, all right? Coterminal means they share the same terminal side. So these are angles, I'm going to make that plural, that have the same terminal side. Yeah, that D is kind of funky. All right, so let's look at A. If I drew an axis and I went negative 45 degrees, so here's 0, moving down 45, okay? This is negative 45 degrees that way, all right? So give me another angle that ends at that terminal side. You know what angle does? If I went at 0 and went around this way, it's always easiest to do the opposite way. All right? Guess what? That's 300. It's positive 315 degrees. How did I figure that out? There should be 360 degrees in a circle. Oh, let's do this. In my circle, all right, if I start here, okay, because look, I have a circle here, don't I? Let me do this in yellow. That's a complete circle. So that's my circle here in case you can't put 2 and 2 together. All right? Now, if I move 45 degrees in this direction, okay, how many degrees are left for this direction? Well, if there's a total of 360, what's 360 minus my 45? 315. So this has to be 315. Because if I take 315 and add it to 45, that gives me my complete circle. The only thing I need to be careful about is, because this one goes this way, this should be negative. And because my 315 goes this way, my 315 is positive. So what's one coterminal angle? It's a positive 315. All right? So really, if I add my numbers up, 45 and 315, that should be 360. But keep in mind that they're going in different directions, so one of them should be negative and one of them should be positive. Okay? Now, I'm going to show you one other thing. But let's do this with, I'll do this with B, the positive angle. All right? Let me get rid of all this here. Cut. So now I'm going to do B, which is 120 degrees. I'm going to put this here. All right. And if I start at 0, 120 degrees is in the middle quadrant, probably somewhere here. This is a positive 120. Okay. So I want an angle that also starts here, that also ends here. But I'm going to go in the opposite direction. Guess what? 240 and 120 give me my 360 degree circle. However, 240 went in a clockwise motion. You got to make sure you tell it, okay, well, I went backwards, so it's negative. Okay? So negative 240 degrees. That's one coterminal angle. There can be so many more coterminal. There's an infinite amount of coterminal angles. Let me show you what I mean. Let me get rid of this negative 240 here for 1 second. And let me show you what I mean. Okay, so what's another angle? I can give you another positive angle. For example, if I started, I'll do this in purple. Hopefully that works. If I start here and I go around and I go past it and I keep on going, that's 360 degrees right there. But then if I go another 120, 360 plus 120. Okay, so technically I have my 360, I went another 120, that's 480 degrees. So in purple, I just went 480 degrees. And guess what? If I go 480 degrees in a positive manner, I will stop at 120. Okay, so I can just keep on adding 360 to 120, then add another 360 and go around again to 100. So I can do that an infinite amount of times. Do I need to? No. I like to keep my angles below 360. But if there was a multiple choice question in a final and said which one of these angles is not a coterminal angle of 120, okay, of course, negative 240 would be listed, and that is a coterminal angle. 480 would be listed. That is a coterminal angle. It'll just do, you just have to see which ones land right there when you plot them, because there can be an infinite amount of coterminal angles. But for the sake of sanity, I'm just doing the opposite direction one so that it's a smaller number. All right, C and D, you can do these on your own, and to be honest with you, we can do these without drawing them, okay? C, if I have 360 degrees in my circle and I go 153 degrees, 7, that turns into a 5, that's 0, 207, okay? So a coterminal angle to 153 is 207. If 153 is positive, my 207 should go in the opposite direction. It should be negative. Let's do the same thing for D, the fourth one. If I have 245 degrees, okay, I have 360 in my circle. I take away my 245. Well, that leaves me 115. So the coterminal angle to 245 is 115. Since this is negative, this will be positive. Bam, 115, that's supposed to be a degree symbol. So is this. Not just a dot. All right, so these are kind of just basic adding, subtracting, looking at it logically, okay, and figuring this stuff out. Okay, here's where poop gets real. As we move forward from here, this is stuff that is going to be useful, that's going to come back again and again and again. In pre-calculus, a little bit, but in calculus, okay? When you need to find an angle, all right, of, let's say, 135 degrees, you need to find the sine of that or cosine of that or whatever. You're going to need to know reference angles, and you're going to need to know two special triangles. And we're about to go over those, okay? So these are things that you want to make sure you get good at, because they might only, show up a little bit here, but in the future they might show up a lot more. Maybe not pre-calculus, but definitely calculus. They're going to be so helpful. All right? A little bit in pre-calculus too. Now, when I graded the January 2019 exams, I noticed, I may be mistaken here, I don't know if there was any trig on there at all. Maybe there was one question. So this might not be abundant for this exam, but this is very important for the future of your math if you're going to keep on going up the ladder. All right? Reference angles. What are reference angles? First of all, they are smaller angles to deal with, okay? So instead of 315, I don't want to deal with 315. I don't want to deal with 120. I don't want to deal with 90. I like 60. That's cool. That's cool. So what I'm going to do here is, and that's what my daughter says sometimes. She's 6. That's cool. Daddy, I like that. I'm like, oh, I like that. I like when you say that. Anyways, back to math. I want to create a reference angle, and I want to make it a smaller angle. I want to make it an angle less than 90 degrees. So reference angle is an acute angle. Okay? It's an acute angle, but here's the kicker. It is always drawn to the x-axis. So if we have our reference angles, okay, if we have an axis and they have a graph 210 degrees on there, or we put our initial ray or our starting side, our terminal ray or our ending side, we're going to create a reference angle from that. And it will always be drawn to the x-axis, never to the y-axis. I will show you as we start doing these right here. That's important. All right? Letter A. I almost said number A. Okay? Let's draw 60 degrees. If I start here at 0, I know this is 90. I know 60 is closer to 90, so I'm going to do that. This is 60 degrees. Guess what? My reference angle is an acute angle always drawn to the x-axis. Here's 60 degrees. It is between my terminal side and the x-axis, so I'm good. So my reference angle is 60 degrees. All right? So I started to get ahead of myself because I got excited. But for each of the following angles, Draw the rotation diagram, which we did. Identify the quadrant that the terminal ray falls in and state the reference angle. Okay, this is in quadrant 1. I just left that out. I'm going to say Q1, and the reference angle is 60. A is done. Let's do B. Here. 315 degrees. 315 degrees. I am going to start my initial side here. I know 315. Okay, here's 0, 90, 180. I just get in this habit. I mean, you don't have to do it all the time when you get good at this, but I like labeling things. I like when someone sees my work and says, man, that's good. I don't know. I have some pride in it. There's 270, and then come back to 360. I know 315 degrees is going to fall in quadrant 4. I almost said 3. Quadrant 4. That's the last quadrant. So it starts here. 315 is exactly in between them. This is 315 degrees. My reference angle is the angle I draw between my terminal side and the x-axis. Let me stress that again. The x-axis. Okay? If you didn't know, this is your x-axis right there. Okay? So, how do I know that'd be 45 degrees? Because if I add 45 to 315, I get to my 360. So ultimately, what we're going to do is we're going to draw triangles here. And if this is a right angle, and this is 45, I now have a 45, 45, 90 triangle. And that's going to really help me figure out like values of angles and whatnot. So never draw your angle to the y-axis. You might say, oh, well, this is 45 as well. That's just a coincidence for your angle being 45. Okay? This angle right here, if I draw it to the y-axis, is still 45. That's the only angle in 90 degrees. Okay, from 0, any number between 0 and 90. 1, 2, 3, all the way to 89. 45 is the only one that happens. The rest of them you would get wrong. Okay, so just get in the habit of drawing that to your x-axis. C. Okay, no, I didn't write that. I said the reference angle is 45. But I did not clearly state that. Again, pride in my work. 210 degrees. If you want to do C and D, go ahead, because I'm about to do these now. All right, 210 degrees. This is 0, 90, 180, 270, and back to 360. I know that 210 degrees is in quadrant 3. It is more than 180. It is less than 270. So if I have a starting angle, I don't know, it'll be slightly closer to 180. From here to here is 210 degrees. So what's my reference angle? My reference angle is from my x-axis to here, okay, to the terminal side. So if I start at 180 and I go to 210, that's 30. And if I were to draw a special triangle, which we're about to cover, I'm foreshadowing what we're about to do here. If I draw a straight line, this would be 90 degrees, and I would have a 30 degree here, 60 degree here, 90 degree there. So the 60 is not my reference angle. The 30 is. It's the one drawn from your terminal side to your x-axis, right in the middle here. Okay? My reference angle is 30 degrees. Last but not least, 120. 0, 90, 180. There it is. 120 is between 90 and 180. So I know that's going to be quadrant 2. If I start here, 120 is actually closer to 90 than it is to 180. Here's 120. My reference angle goes from my terminal side to the x-axis. How do I get from 120 to 180? Well, it's 60 more degrees. So if I did a triangle, that would still be a 30, 60, 90. But my reference angle is 60 degrees. Okay? That might not seem difficult. It isn't. And if you can remember the next thing we're about to do, I believe we're about to do the 2 special triangles now, you'll be able to like get values like you wouldn't believe, and you'll be like, oh, this is easy, not too bad, because it isn't. Okay, special right triangles. This is it. This is the money shot here. We have two triangles here, and we have a 45, 45, 90, which is this one on the left. This is 45 degrees. This is the same measurement, 45 degrees. This is 90. All right. And we have a 30, 60, 90 triangle. This is 30 degrees. That's the smaller angle. This is 60 degrees. That's the larger of the two angles that are not right angles. And this is our right angle, 90. Now, it says label the angles and the sides. Listen. The sides of a 45, 45, 90 triangle are always going to be 1, 1, 2. Now, wait, I'm not done. Okay? 1 and 1 is 2. The last number in the sequence is always square root. Okay? 1 and 1 is 2. That's how you remember it. Okay? I'll give you another way in a moment. Now, for this 30, 60, 90 triangle, I'm going to use the numbers. I'm just going to count. 1, 2, and 3. And just like the last term gets the radical here, the last term gets the radical here. All right? Now, my hypotenuse is always the largest value. This is technically, I think it's 1.414, blah, 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 blah. That's bigger than 1, so that should be my hypotenuse. Okay? Radical 3, I think, is 1.7 something, or 1.866 or something. But 2 is bigger than this. So that's the biggest here. 1 is the smallest. That should be across from the smallest angle in radical 3. All right? So if I think 1, 1 in radical 2, and I know 1, 2 radical 3, oh, but which one's which? Remember, if two angles are the same here, then the two sides should be the same here. Okay, so your 1, 1, 2, radical 2, should be your 45, 45, 90. Okay? Your 1, 2, 3, well, that's your 30, 60, 90. Okay? So, how are these important? Let me explain something to you, children. SOHCAHTOA. They're important for trig because sine equals opposite over hypotenuse. Okay. Cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent. There are many different ways to remember SOHCAHTOA, but my students seem to like some old hoe caught another hoe tricking on Alexander. No, catch that old hoe now. Okay? So some old, yeah, sorry, my bad. But I just love it. And the kids love it, and they remember it. And I don't care how they remember it, as long as they're not dropping, like, curse words in here or whatever the case might be. But sine equals opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So if I want to know what the sine of 30 degrees is, if I was looking at this angle, opposite is my 1, adjacent, which means next to, is my radical 3, and this is my hypotenuse, okay? So why is that important? Let's go back here to these problems we just did. I don't know what the sine of 210 is, but don't I have a 30, 60, 90 triangle? I know I can figure out what the sine of 30 is by using my triangle, and that's exactly what we're about to do, okay? Let's actually do some of these. Let's find the measurement of each angle. I think we got 2 of these. Oh, we got some more practice, which I think I'm going to let you guys do for homework. But, okay, here we go. Now, this first one here. If I have a coordinate, this is my x and this is my y. Okay, that's a y, not an x. And I draw a triangle down here. My x value is how far I go to the left, -1. My y value is how far I go up, radical 3. That means, 1 radical 3, 2. That's a 30, 60, 90 triangle. My radical 3 is across from my 60, isn't it? It is. So my radical 3 is across from my 60. If that angle in there is 60, okay, and this is 90 and this is 180, what angle is 60 degrees in front of 180? Okay, I stopped 60 degrees short of 180. That's 100, from here to here is 120 degrees, because 120 and 60 give me my 180. Let's do another one. We have a triangle here. Should really blow these up. I go -1 this way and -1 this way. 1, 1, radical 2. I know this has to be 45 degrees, okay? So that's 45 degrees right in there. If this is 180, I just went 45 degrees past that. 180 plus 45, 225. Okay, so now I'm going 225, but be careful. Look at the direction. The angle goes this way, it should be negative. All right, so this is 0. This is -90. I just went 45 more degrees this way. Another negative, I guess we'll call it. So we'll say 90 and -45 give me -135. I actually have -135, which is a coterminal angle to 225. All right, but this is your answer because that's the angle they gave us on the bottom. So why don't you guys do these practice ones on your own? I'm not going to do them here because I'm going to have my kids do them for homework and give them another sheet. I want them to do this. So take it easy. That's it. And I will see you for Unit 3, Lesson 2. Be nice.